Hello, in this hello, we are going to discuss the equivalent resistance of the cube and equivalent resistance across AZ point, across AB point, across AF point and across BF point as well as across BG point. So here we have given the one cube. In that cube at each edge we have attached the resistance, that is R. So all resistance are of same value. So this if we want to calculate the equivalent resistance, then this circuit we want to convert in equivalent circuit, or by using Kirchhoff's law also we can calculate the equivalent resistance. So first we will convert this circuit in simple circuit. So here what will happen, this is the A terminal, this is the B terminal, this is the C terminal, this is the D terminal, this is the E terminal, this is the F, this is the G and this is the H terminal. So this is the A terminal is connected to the E terminal, B terminal and D terminal. So A terminal is connected to the E terminal, B terminal and D terminal. So then this D terminal is divided in C terminal and H terminal. This E is divided in C and H terminal. Then this E terminal is divided into F and H. This E terminal is divided in F and H, and this B terminal is divided in F and C. So this B terminal is divided in F and C. Then this F terminal. So here what will happen? So this B terminal is coming toward the F. So this F we have connected, this HH we have connected, and this CC we have connected. So this H is coming toward the G terminal. So this C is coming toward the G terminal, this F is coming toward the G terminal, and as well as this H is coming toward the G terminal, C is coming to the G terminal, and this F terminal also coming toward the G terminal. So this cubic circuit we have converted in equivalent circuit. So here what will happen, here is this E point, B point and D point. So this E point, B point and D point are equivalent point. So similarly this F point, this C point and this H point are equivalent point. So that's why this is the equivalent point. So current, so here is, we can say that this is the equipotential. So this is also the equipotential. So due to the equipotential we can connected this point. So this point we have connected, this F G point also we have connected. So here these three resistance, this resistance, this resistance, this resistance across AE, AB and AD respectively we have connected in parallel. So according to the parallel, if the resistance are connected in parallel, that equivalent resistance we have calculated by using such type of formula. So here these three resistance having the equivalent resistance, that is the 1 upon RT dash, that is equal to 1 upon R plus 1 upon R plus 1 upon R. So this is the 1 upon RT dash is equal to 3 by R. So RT dash is equal to R by 3. So this three resistance is equal to the, this is connected in parallel, so that total resistance of this three resistance, that is equal to the RT dash is equal to R by 3. Similarly these six resistance are connected in parallel. So 1 upon RT dash double dash is equal to 1 upon R plus 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 1 upon R, that is the 1 upon RT double dash is equal to 6 by R, or RT double dash is equal to R by 6. So this 6 parallel resistance, that is equal to the RT double dash is equal to R by 6. Similarly these three resistance are in parallel. So that's 1 upon RT triple dash, that is equal to 1 upon R plus 1 upon R plus 1 upon R, that is equal to 1 upon RT triple dash is equal to 3 by R, and RT triple dash is equal to R by 3. Then this, so these three resistance, that is equal to R by 3. So this is the R by 3. Then this you have connected this 6 resistance, that 6 resistance is equivalent to the R by 6. So this is the R by 6, and this 3 resistance, that is the R by 3. So this is the R by 3. So this Now this circuit we have converted into equivalent circuit. So this three resistance is connected in series. So we are familiar with that the resistance are connected in series, so they get added. So this R by 3, so this resistance RT dash, this RT dash, RT double dash and RT triple dash are in series, so they get added. So resistance across A to Z, so that is A to Z is the A to Z. So that resistance across A to Z, that is equal to RT, that is equal to RT dash plus RT double dash plus RT triple dash. So a resistance across AZ, that is equal to RT, that is equal to R divided by 3 plus R divided by 6 plus R divided by 3. So this we can convert the denominator as equivalent. So we have multiplied by this by 2 and divided by 2. So this is the 2R divided by 2 multiplied by 3, that is the 6 plus R by 6. Similarly here we have multiplied and divided by denominator and denominator by 2. So that is the 2R divided by 2 multiplied by 3, that is the 6. So this we have added. So this is the 2R plus 2R, 4R plus R, that is the 5R divided by 6. So resistance across RAZ, or that is the R total, that is equal to 5R divided by 6. So this is the resistance across AZ. Now the resistance across AB. So resistance across A to B. So resistance across A to B. So three resistance are in parallel. So that equivalent resistance is R by 3. So resistance across AB as well as AE as well as AD, that is the R by 3. Similarly resistance across E to F, B to H, D to C, that is equal to R by 6, and resistance across F to Z, H to Z, C to Z, that is the R by 3. So here we have calculated the resistance across AB, that is equal to R by 3. Resistance across AB, that is the R by 3. Resistance across FZ, that is the R by 3. Resistance across BF, so resistance across this BF, that is the R by 6. And resistance across AF, resistance across AF, so resistance across this A to F. So resistance across A to F, that is the resistance across A to F, that is the, this is in series, so R by 3 plus R by 6. So R by 3 plus R by 6, so that is the 2R. So here we have multiplied by 2 numerator as well as denominator, so 2R divided by 6 plus R by 6. So this we can write 3R divided by 6, so that is the R by 2. So resistance across AF, resistance across AF, that is equal to the R by 2. So in this way we have calculated the resistance by using the equivalent circuit. Now same problem we can solve by using the Kirchhoff's voltage law. So here, suppose here we have considered this is the A to Z. So here we have connected the voltage, that we have connected the battery. So this we have considered the loop. So here what will happen? This all resistance, that is equal to, we have considered the equivalent resistance, that is the AZ, and here we have connected the battery. And suppose here just we have considered the 3I current is passing through this I. So 3I current is passing through this. So here what will happen? According to the Kirchhoff's current law, this current 3I current is divided in this part, in this part, in this part. So this current we have considered 1I, this is 1I, this is the 1I. This current is coming in this side, so this 1I current is divided in two parts, so that is the I by 2, and again this current is coming here, that is the I by 2. Similarly this 1I current is coming here, so that is also divided by I by 2, and here is coming I by 2. So this is coming I by 2, they get combined and it will the 1I. So here we will get the 1I. Similarly from this side 1I, so 3I current is coming again toward the negative terminal of the battery. So here we have considered the RAZ, that is equal to, here what will happen? Here we have considered the voltage, and that current according to the Ohm's law, V is equal to IR, and R is equal to V by RI. So I, that we have considered the 3I, and voltage is V. So here this RAZ resistance we want to find. So according to the Kirchhoff's voltage law, from loop we have considered the loop A, D, H, G, I, J, and again A. So here we have considered the A, D, H, G, H, J, A loop. So here we are going from the positive terminal to the negative terminal. So potential get decreases. So here we have get the sign minus IR. So this current we have considered IR minus. So here this is the resistance is R. So this we have considered the this resistance is, so A to D. So we are moving from A to D. So current is I. So 1I, that is the IR. Then D to H. So D to H, that is the half current. So that is the half I by 2R. Then this is the minus IR, because we are moving from positive terminal to negative terminal. So there is the minus sign. So IR. So here now what will happen? We are coming here. So we are moving from negative terminal to positive terminals, from I to J. So here we have take the positive sign. This is the positive. This voltage is V, that is equal to 0. So this we have this IR minus IR, that is the minus 2IR minus this IR divided by 2 is plus V is equal to 0. So this we can write this 2 we have multiplied by in this side, and we have taken we have making the denominator same. So this is the 4IR minus IR divided by 2 plus V is equal to 0. So this is the 4IR minus IR, that is the minus 5IR divided by 2 plus V is equal to 0. So V is equal to, we can write this is the equal to sign here minus sign get cancelled. So this it become positive when it came above the equal sign. So V is equal to 5IR divided by 2. So this is our equation. So putting equation 2 in equation 1. So this voltage we have putting in equation 1. So IAZ, so resistance across IAZ, that is the diagonal resistance across the cube, that is the AZ. So RAZ, that is equal to V by 3I. So V is equal to, we will get 5IR divided by 2. So this RAZ, that is equal to V by I. So V is equal to this 5IR divided by 2, and I, that currently we have considered, that is the 3I current, that here we have considered the 3I current. So this is the 3I. So here this we can write 5IR divided by this 3 multiplied by 2, that is the 6I, and this II get cancelled. So resistance across RAZ, that is equal to 5R divided by 6. So in this way we have calculated the equivalent resistance across diagonal of the cube, that is the RAZ. So that is, this is the 5R divided by 6. Similarly, by equivalent circuit also we have calculated, that is equal to the 5R by 6. So here we have calculated the resistance by using by converting the equivalent circuit, as well as by using the Kirchhoff's voltage law. So if we have given the capacitance, if C capacitance is connected across each edge of the cube, then what is the equivalent capacitance of the cube at different points? So this point we are going to discuss in next lecture. The link of that lecture is given below description box. Thank you very much for watching this video. Thank you.